Hello viewers, I am Kausalya. Today we are going to solve example 8 in chapter 12. So here the topic is conversion of solid from one shape to other. So here what are all the different shapes we are discussing about? So previously in volume topic we have discussed about cylinder, cone, right, sphere and cuboid. So again now we are going to convert one shape to another. That is, it may be we can convert a cone into a cylinder and cylinder into a sphere and vice versa, right? So example 8, a cone of height 24 centimeter and radius of base is 6 centimeter is made up of a modeling clay. So here we have a cone whose dimensions are given, right? Whose height and radius is given. Next, a child reshapes it in the form of a sphere. Now, a child is going to modify this cone into a sphere, right? So, this cone is converted into a sphere now. So, find the radius of the sphere. We have to find the radius, right? So, what it indirectly means is, you see, here the volume of the cone will be equal to the volume of the sphere because here the cone is converted into a sphere, right? So first we start our answer with, you see here the cone is converted into a sphere, therefore volume of the cone is equal to volume of the sphere, right? So here the parameters are h is 24 and r is 6 centimeter. And here we have to find the radius of the sphere, right? Now what is the formula? You see volume of the cone is given by 1 by 3 pi r square h and volume of the sphere is given by 4 by 3 pi r cube, right? Now here we know r and h values and here we have to find the value of r. So just substitute the values, right? So in this case you see pi is common in both the terms. So we can cancel out pi and again you see we have 3 in the denominator. So we can cancel this 3 also, right? So the remaining things are, you see 6 into 6 into 24 here and here 4 into r cube, right? Now I am going to move this 4 to the left hand side. So here it is in multiplication part, therefore here it occupies the division part, that is denominator. Now you see while cancelling, okay, just be little bit aware, right? You see when you have 4, you just don't go and strike with this 6, right? You see here we have a cube, right? Anyway we have to find a number, right? And you have to take the cubic root. So you see when you cancel this 4 and 24, again here we have a 6, which makes this term as 6 cube, right? So therefore it is easy for us to take the cubic root, right? Therefore, so okay, don't be in an urgent to cancel this 6 and 4 by 2, right? Better, okay, cancel these two terms so that it will make your calculation easier, right? So you see 4 and 24 they cancel by 6. Now we have 6 into 6 into 6, which is 6 cube. Right, so 6 cube is equal to r cube, therefore r is equal to 6 centimeter. Right, therefore here you see the radius of the sphere is 6 centimeters. Right, we will proceed with the next problem. Example 9. The problem is, Selvi's house has an overhead tank in the shape of a cylinder. This is filled by pumping water from a sump which is in the shape of a cuboid. So here comes two different shapes, right? One is a cylinder and another one is in the shape of a cuboid, right? So you see the sump has dimensions, that is the cuboid has its dimensions as 1.57 meter into 1.44 meter into 95 centimeter, right? Now the overhead tank has its radius as 60 centimeter and height as 95 centimeter. So what is the shape of this overhead tank? This is in the form of a cylinder. Therefore, the cylinder radius and cylinder height is given. Next is, find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump which had been full. So here, okay, read this sentence twice because it is a lengthy sentence, right? Find the height of the water left in the sump. So here, where is the sump here? So sump is nothing but cuboid, right? You have to find the height of the water in the cuboid. When you have to find the height? When the overhead tank is full, right? So that is explained in a big sentence. You see, overhead tank had been completely filled with water from the sump which had been full. That is, you see, initially the cuboid is totally full. Okay. Then after that, we are pumping water from the cuboid to the overhead tank which is in the form of a cylinder. Now what happens? The overhead tank is totally filled with water. That is, the cylinder is completely filled with water. Now you have to find the height of water which is left in the sump. That is, which is left in the cuboid. Right. So wait, let me explain you people with this diagram. So this is the diagram, right? So this is the sump which is in the form of a cuboid, and this is your overhead tank which is in the form of a cylinder, right? Initially, you see the cuboid is completely filled with water, right? So here initially it is totally filled with water. Now when you switch on the motor, right? Motor pumps the water from this sump to the overhead tank, right? Now the overhead tank is completely filled with water, right? So you see the motor pumps the water from this cuboid, from this sump to the overhead tank, right? So when it is pumping water from the sump, what happens to the water level? The water level in the sump gets automatically reduced, right? So initially the water is full, right? Now after pumping water to the overhead tank, the water level has reduced, okay, like this. Now you have to find the height of this water level in the sump, right? Provided the condition is now your overhead tank is completely filled with water, right? So am I making the problem clear? I hope so, right? So now we will proceed with the calculations. So here we are discussing about the water. So the water capacity purely depends upon the volume, right? I believe you people know what is volume, right? When you have a tumbler, when the tumbler is completely filled with water, how you will calculate the volume of the water or volume of a water bottle? Even you can take a water bottle, right? If it is a 1 liter water bottle, then it can hold only 1 liter of water in it, right? Similarly, that is the main reason why we are always calculating volume whenever we are discussing with the liquids, right? So here we are discussing about water, right? So now we are going to calculate the volume of the sump, okay? So this is your sump and this is your overhead tank. So now we are going to find the volume of this tank as well as this sump. So first I start with sump. So sump is in the form of a cuboid, right? So what is the formula to calculate the volume of the cuboid? It is nothing but L into B into H, right? So this is your L and this is your B and this is your H, right? So this is the total capacity, okay? This is the dimensions of this cuboid. Now we are going to find the volume of the cylinder. So here you see, again I forgot to tell this thing. You see here these two terms are in meter and this is in centimeter, right? So now I am going to convert this centimeter to meter. Therefore I am dividing this 95 by 100. So which is 0.95 meter, right? So always beware of the dimensions. Okay, even if you make a small mistake in this unit, then finally your entire answer will be wrong. Right, so now I have converted these three terms in the form of meter, right? Now next we will proceed with cylinder. So here cylinder, what are all the given things you see? They had given the radius and height. Right, these two terms are in centimeter, so just convert this to meter. So 60 by 100 gives you 0.6 and again 95 by 100 gives 0.95 meter, right? Now all the dimensions are in meter, right? Just make a check. Now volume of the water in the tank. So the tank is in the form of a cylinder, right? So what is the formula of the volume of cylinder? It is pi r square h. So pi is 3.14 and r is 0.6 and h is 0.95. Since we are discussing with volume, here you have to mention the unit. It is mandatory. So here it is meter cube, right? The next one is volume of the sump, that is volume of the cuboid, which is L into B into H. So just write as such. Right. Now to find the volume of water left in the sump, that is volume of water left in the cuboid. Right. So again, when you look back at the diagram, you see we are pumping water from this cuboid to this tank. Right. So here the cuboid capacity is more because even after filling this tank with water completely, this sump has some water in it, right? Therefore, now this sump has the higher capacity and this tank has considerably some lesser capacity. Now we are going to subtract this volume of this water in the tank from the volume of the sump. Right. Now sump is a bigger number, right? Just assume like that. Now sump has a capacity of some 100. For example, I am telling, okay, just in order to make you people understand the concept clear, I am explaining like this, right? So here, for example, I assume the value of the sump is 100 and let this value of this tank be some 40. Right. Now how you will subtract? You will subtract 40 from this 100, right? Similarly, here I am subtracting the volume of water in the sump minus volume of water in the tank because sump has a higher capacity. So what is the volume of water in the sump? We have calculated, that is volume of the cuboid and this is the volume of the cylinder. Right. So just substitute. Next, in order to make our calculation simpler, you see, I can write this 1.44 as 0.6 into 2.4 because here I have a term 0.6. Right. So what I have did is just I have divided this 1.44 by 0.6. You see 1.44 divided by 0.6. Right. So just remove the decimal point. So here it becomes 144. Okay, I know you people know how to remove the decimal points, right? So here after this dot I have 2 digits, so multiply by 100 and again divide by 100. So this 1.44 becomes 144 and when this 0.6 multiplied by 100 it becomes 60. Right. So once you simplify here, you will be ending up with the answer as 2.4. Right. So this 1.44 is written as 0.6 times of 2.4. Right. And again you see here I have 3.14, right? So this 3.14 can be written as 2 times of 1.57. Right. Even you can directly multiply and you can get the answer. Okay, that's not an issue. But here in order to make our calculation simpler, just find, okay, try to relate these terms with these terms. So it will be very easier for you to solve. So now when you compare these two terms, you see I have 1.57 and here also 1.57. So 1.57 is a common term. And next you see I have 0.6. So here also 0.6. And next is 0.95 and here also it is 0.95. Right. So just take these common terms outside and the remaining term here is 2.4 and here it is 2 into 0.6. Right. So 2 into 0.6 is 1.2 and again 2.4 minus 1.2 gives you 1.2. So this is the volume of the water, right, which is left in the sump or which is left in the cuboid. Right. Now we have to find the height. Right. I want to find the height of the water level in the cuboid. So what is the formula for the volume of the cuboid? It is L into B into H, which is nothing but this value. Right. Am I making clear here? So this is the volume of the water which is left in the cuboid. right? So this volume is given by the formula L into B into H. I again insist you never get confused with the original dimensions of the cuboid. Now we are discussing about the water level, right? So again, initially I told you now the water level depends upon the volume of the container. So similarly, now just it is reversed. Now I know the water level and now I am going to find the height, right? So this volume of the water is given by L into B into H, which is equal to this term, okay, these numbers. So just write it as such. Now I need to find the height, right? Because water level is the only thing that goes ups and down, okay, right? So here you see what is the length and breadth of the cuboid. Here again we will look back into the problem. You see this is the length and this is the breadth, right? And H we are going to find because H is nothing but height of the water level which will vary, right? So in the place of L and B, just write the numbers, okay? Write the dimensions, and H is the varying quantity. So we are keeping it as H. So which is equal to this number, right? Again, you see when you cancel the common terms, okay, in order to find H, I am moving these terms to the denominator part and just cancel the common terms. Again, you see we have decimal numbers. So in order to remove these decimal points, you see I have after this point 1 digit and after this point 2 digit and again after this point 1. So 1, 2, 3, 4. So just multiply and divide by 10,000, right, in order to remove these decimal points. So how now it becomes 0.6 becomes 6 into 95 into 12 divided by this. You see when 1.44 gets multiplied by this 10,000, it becomes 14400, right? Now just cancel the common terms. You see 12 and this 14400, they cancel by 1200 times, right? So because 12 12s are 144. So here it is 1 time, here it is 12 time, and these two zeros here. And again I am cancelling this 6 and 1200. So when you cancel this 6 and 1200, it becomes 200. Therefore H is 95 by 200, and once you simplify, we are ending up with the answer as 0.475 meter, right? So this is the height of the water in the cuboid when your overhead tank is completely filled, right? So this is the height of the water. Now we are going to compare the capacity, because this is also another part of your question. Compare the capacity of the tank with that of the sump. So capacity of the tank by capacity of the sump, right? And again it is up to you. Even you can write capacity of the sump by capacity of the tank, right? Because that doesn't make any difference. So capacity of the tank, it is nothing but it is the volume of the cylinder. So just write down the value. And capacity of the sump is nothing but volume of the cuboid. So just write down the values. Again you see these two terms, they cancel each other, and again in order to remove the decimal points, I am multiplying by 10,000, because you see here after this point 2 digit and after this dot 1 digit, after this dot 1 digit. So 1, 2, 3 and 4, therefore I am multiplying by 10,000, 4 zeros, right? Similarly, again here also, because once you are done with the numerator, again you have to multiply and divide by the same number, okay? Don't here multiply by 10,000 and here divide by simply 1,000, okay? It's an error. So just multiply and divide with the same number. Now what happens, you see our numbers get simplified. Here it is 314, here 6 and 6, and here 157 into 144. Right. So again cancel. So when you cancel the common terms, finally here we are ending up with 2 by 4. You see 2 times of 157 gives you 314, right? So they cancel by 2 times. And again when you cancel by 6, this 144, it becomes 24 first, and again when you cancel by another 6, it becomes 4, right? So sorry. Yeah, 24 and 4. So finally here the answer is 2 by 4, which is 1 by 2, right? So now you can write it as, you see, the capacity of the tank is 1 by 2 is nothing but half, right? So I am moving this to the numerator part, therefore it becomes multiplication, right? Here it is division and it occupies the numerator part on the right side. Therefore, capacity of the tank is half of the capacity of the sum, right? So finally, this is our answer. I hope you people understand this problem. If you have any doubt, let me know in the comment section. Thank you.